Hello. Correlation coefficient. The symbol is R. R tells us if there is a positive or negative relationship, linear relationship. R is going to be less than or equal to 1 or greater than or equal to -1. The closer to 1 and the closer to -1, there's evidence that the relationship is stronger. Closer to 0, either from either end, positive or negative, the relationship is pretty weak to a point that there's not any linear relationship. So if I look at A, my R is negative. R is negative means my slope is negative. If my slope is negative, I have a decreasing uh, line. That means my answer is either I or 3I. I have two negatives, two negative R values. So I would say A is 3I because this value is closer to -1, which makes a stronger relationship, meaning the points are around a um, straight line that goes through all the points. And B will be, I would say, I, because the points are more scattered around. And C is R is 0.434, D is R is 0.837, R is 0.998. So they're all positive. That means my slope is positive. That means I have an increasing line. So if I look at these three options left, the highest number is close to 1 is E. So I would say E here is the fifth one. And then I would go with, for D, double E, it's more scattered. And this one is much more scattered, which is an R value close to 0. So I would say then it is this one. All right, so next, suppose that you have data on each of the following. For which pairs would you expect the correlation coefficient to be close to +1, close to -1, and for which you expect R to be close to 0? So if I look at A young child's height and weight, I would say close to 1. Positive. As the child grows, the weight grows. Should be similar. It should be proportionally. B, the age of a car and its book value, I would say that is close to -1 because as the car ages, it loses value. So it's -1. Child's shoe size and the number of words in the child's vocabulary. I don't think there is a relationship. I'm saying this as the child grows, the shoe size grows a little bit. I would say it's a positive um, value, but not close to 1. But not close to 1. I don't see any relationship between the shoe size and the child's vocabulary much. Okay. D, the number of hours per week that a student studies and the amount of money spent on food each week. I think there's really not any relationship between these two, so I would say it's close to 0. E, the number of hours per week that a student studies and the resulting GPA, I would say this is positive. The more I work, the better result I'm likely to get from GPA. So I would say close to 1. The number of cartons of cigarettes sold in the United States and the tax revenue on the cigarettes. So the more it's sold, the more tax. I am I am guessing, so I would say close to 1. It's positive and close to 1. The number of hours a person sleeps nightly on average, the number of push-ups the person can do. Well, I would say this is close to 0. I don't see much linear relationship going on. The following table gives the percentage of U.S. gross domestic product spent on healthcare over the years. Is there a significant level of linear correlation between these two variables? If so, what is the regression line? Estimate the percentage, and so forth. Let's find the first. Let's go to our Smart View and L1. I have the values. L2, I have the values. L1 represents time. L2 represent the percentages, 4.4% and so forth. And second dot plot, it should be on, and then type is scatter, but I want to use L1, not L3, L4 list. So I'm gonna go for L1. So second one is my L1, and then second 2 is my L2, and hit enter. Okay. And then I'm going to look at second catalog, and then letter D and alpha D, and scroll down to diagnostics on to be able to obtain the value R. Hit enter, hit enter. And then stat, um, or let's graph it first. Let's go to window. I want my X-min, let's say 1950, X-max 2000, and let's say every 200. And Y-min is, let's say, from 0 to Y-max of 15% every 1. And graph. Now this is my scatter diagram. Now I want to find the R, stat, calc, for, and I have several lists, so I want to choose L1 and L2. So I'm going to, my L1 is second L1, comma, second L2, enter. So this is my linear regression. All right. And so I'm going to capture my linear regression and copy it right here. Okay. So now, so if it is in the AX plus B form, so my linear regression is y 0.254. Let's say instead of y, that is my population in terms of time, minus 493.825. So this is my a regression line. So A and B, I plug those in. My R is 0.992. And then because my sample size is 4, 8, I have 1, 2, 3, 4, 5, 6, 7, 8 values. N is 8. My Rn is 0.707. Because my R is greater than R sub n, I'm going to say that there is significant level of linear correlation between these two variables. So I answered my question up to here. Okay, and the next question was, if so, what is the regression line? This is the answer for my equation of my regression line. Okay, and let's go back here. If I wanted to graph, go to Y. If I wanted to graph a variables 5 to statistics and scroll right to equation and 1, hit enter, and I picked up my values and graph. Then this is the graph of 0.254t minus 493.825. All right, my R is positive, so it is an increasing line, as you see. All right, and then let's minimize this question. To answer, estimate the percentage of GDP on healthcare in 2000. So P is equal to 0.254 times 2000 minus 493.825. This should be equal to 14.18 point 14.18 percent. So I can say the regression equation gives 14.2% as an estimate for population when T is 2000. And the rest of the question is, if current trends continue, when will 20% of GDP be spent on healthcare? That is, what is T? So 20% is, in my model, T plus 4.575. So I'm going to subtract first, 4.575. This is 0. So I'm going to end up here 20 minus 4.575 is 15,425.254t. Then I'm going to divide both sides by 0.254, 0.254, and t is equal to, this is a 1 then, and divide this by 0.254. 60.73. And if I add this at this value, 60.73 onto 1960, your starting year, 2020.7. So our equation predicts that if current trend continues, spending on healthcare will reach 20% in about, so what I did here is 1960 plus 60.73 gives me 220 point, oops, around 2021 will be the answer. All right, next question. One of the most famous moments in the history, um, reported the experiment of dropping various objects from the top of a 180-foot high leaning tower of Pisa and discovering that they fell at the same rate regardless of their weight. The following table gives the speed v in feet per second of an object dropped from the top. Negative values for the speed simply reflect the convention that velocity is considered positive when an object is moving upward and negative when an object is moving downward. Note how the object starts to fall slowly and then accelerates. Does the correlation coefficient indicate a significant level of correlation between A and B, between two variables? That means I need to find R, I need to find Rn. Let's go back to our calculator. Okay, I'm going to look at my stats, edit. So these values are in list L3 and L4. I put those values in. And then first I'd like to go to second stat, enter, and enter, scroll down. Now I want my X list L3, which is second 3, enter, and I want L4. That will be second L4, enter. And you will see the graph. Let's look at my window. I want time x from 0 to, let's say, 4, increments of, let's say, 0.5. I want y from, actually, from negative 100 to 0. Let's say every 10. Graph. Okay, this is my graph. And then I'm going to find stat, calc, linear regression, but I want to use L3 and L4. If I don't put it in, it automatically picks up L1 and L2. So L3 is second 3, comma, second L4, enter. So this is my value. All right, I'm going to screenshot really quick and paste it over here, let's say. And then I'm gonna go back and copy my R right here to be able to compare. All right. So now my R is 0.99 and my sample size is 3, 4, 5, 6, 7, N is 7, and my Rn is 0.754, and I compare. So here R is negative 0.999, so forth. Okay, and it's very much close to -1, and my Rn, because my R is negative, my slope is negative, I'm going to take my Rn as negative 0.754. So if R is less than Rn, then there is a significant level of correlation. All right, to answer A, uh, yes. And because R is very close to -1 and less than R sub n, there's uh, there's a significant level of correlation. Now, to find B, the best fit line comes from A and B. So Y is equal to, here, let's call it V because that's my outcome. The speed is equal to negative 32.05 time plus B 0.01786, let's say. So this is the answer for B. To answer C, what is the significance of the slope in the equation? My slope is negative 32.05 t, and this is the change in the speed to change in time, and speed comes in feet per second and time is in second. And the units for the slope will be then you can do simple algebra here too, feet per second over 1. This is feet per second, multiply upside down, feet per second square. So it will be feet per second square is the units for the slope. The slope is negative because the object is falling downward ever faster. The specific value for the slope is approximately negative 32 feet per second square, which is the acceleration due to gravity. Due to gravity. Hope this helps. I'll see you next video. Thank you.